Hello everyone and welcome to our webinar. Thank you for joining us this afternoon. My name is Riyad. I'm studying for a master's degree in Oilfield Mechanical Engineering at the Faculty of Hydrocarbons and Chemistry, University of Medea, Algeria. And I'll be your moderator in today's session. Today we are pleased to welcome Mr. Chemaa Khaled, very special guest from Schlumberger. Mr. Chemaa has PhD in Mechanical Engineering, Digital Mechanics and Materials, Intern Student Researcher in the Center for Development of Advanced Technology, CDTA. He is a researcher in the Laboratory of Mechanics, Physics, and Mathematical Modeling at Medea University. Mr. Chemaa is a maintenance engineer at Schlumberger, and he is an author of 2 books and multiple scientific papers and international communications concerning tribology, thin films, coatings, and materials. And today, he is going to share with us his experience and his knowledge on maintenance engineering. If you haven't already, please make sure to check out YouTube channel and test for the latest updates. Please feel free to answer your questions in the chat box, and we will answer them at the end of the presentation. Mr. Chemaa, thank you so much for being our today's guest, and you can start in a few seconds. Hello, sir. Could you hear me?
Yeah, I'm hearing you. Thank you, Riyad. Thank you very much for such a wonderful introduction. In fact, today we are going to have a session about the introduction to maintenance engineering. In this short introduction, I will not go through a lot of theoretical things. I'm just going to be superficial, because I know that there is a lot of people here, a lot of audiences here that are not in the domain, that are not in the maintenance domain. So I want to keep superficial in this introduction. The second point that I want to say it before starting our session today is that we are focusing in this introduction on mechanical domain, because in maintenance, you know, we have some electrical equipment, maintenance in electromechanics things and stuff. But in our session today, we are going to focus more on mechanical parts and mechanical equipment. So to start our session today, there is 2 definitions that we should put in our hand, and to understand them very carefully. The first definition is maintenance. What does it mean, maintenance? What is this? What is its standardized definition of maintenance? Maintenance is any activity intended to retain or restore. And here, I want to stop to say something. Retain, what does it mean, retain? Retain means that the maintenance person has a mission to keep his equipment to perform, keep it performing in its best state and best performance, and to save it and keep it safe from any failure. However, the words restore means that any actions that the maintenance person gives to this equipment after the failure happening, which means corrective actions. I continue the definition: in or to a specified state. Specified state means has also a meaning, because this specified state of the equipment depends on the sector of application. For example, in some critical sectors such as oil and field industries, aircraft industries, and nuclear industries, these sectors are very dangerous and very critical. So the specified state means not are they working or not, your equipment now, but are they working safely or not? This is the question. However, in some industries, such as productive industries, where we have just short added value of our product, the question that or the specified state is whether our equipment is working or not. That's all. I keep on my definition in which it can perform its required function. I think now this definition is clear. The second definition is the definition of failure. The failure is the state of the asset where it cannot perform the required function. Now, what is the role of the maintenance engineer or the maintenance technician? We have here all your job. All your job is resumed here in this curve. We call this curve the bathtub curve, or the equipment life curve. All your mission can be understood when we understand this curve. This curve is divided on it is a mapping of 3 different curves. The first curve is the early or the infant mortality failures. Those failures are generally, we have these failures generally when we manufacturing our equipment. That means when we have a newborn equipment, a lot of failures happens then. It's just, we can simulate this curve with the life of human body. When we have a new baby, this new baby have a lot of failures to learn how to walk. His body start to recognize the germs and the epidemics until he have his body start to have his immunity. So second part, and this is the most important part, because your job as maintenance engineers started in this step. We have random failures or let's say constant failures. That means the failures that is going to get our equipment are depending on the environment of working. If you have severe environment, we will get a lot of issues, a lot of failures. However, if we have constant working states or conditions, we will get just small amount of failures. So because of that, we can say that we are in a random failure step. The third part, or the third step of life, is the wear out failure. Here, the equipment is too old. It's like a human, it's like an old person. And any small failure can produce and cause a lot of failures, a lot of damages to our equipment. Now, when we map those three curves, that I mean the early failure curve with the constant failures curve and with the wear out failure curve, we get the blue one, which is the life state of the equipment curve. Now, I said before, in the first case, it happens generally when we get new manufactured equipment. This state or this phase, we call it generally the honing phase. In French, we call it la période de rodage. Generally, those failures are controlled and standardized in the manufacturing companies. While when any company purchase new equipment, it will be already in the second phase, which is the constant failures phase. So our role or our jobs as maintenance engineers is to keep our equipment as long as possible in this second phase. We must avoid the maximum arriving into the third phase, the maximum. This is our job. And the best engineer or technician is who extend this period. And the bad one who entered to the third phase just in the beginning. So to resume, to give a conclusion to our jobs as maintenance engineers, let's take these ideas. The first role of maintenance engineer is to increase the longevity of the equipment. I mean longevity, the second phase of life. Second role is to enhance the availability of the equipment. I mean by availability, the equipment must be ready for any time to the exploitation team. The third role is to reduce the failure cost. And I mean the direct cost and the indirect costs. The direct costs are the cost of salary of the maintenance team, the cost of spares, the cost of lubricant, energy, and the indirect costs are the cost of the non-productive periods. For example, if you maintain badly your equipment, we will have a lot of non-productive times. The fourth main role for maintenance engineer is to avoid the risk of failures, especially in critical sectors where any risk can kill you. It's like that in oil field or gas engineer or gas industries. Any failure can kill you. Now, to understand what's happening in reality within our equipment during those three steps, we need to use science. We call it tribology. A lot of you doesn't hear about this science before, but for maintenance engineer, this is the main science for him. This is his utility or tool to understand what's happening exactly for his equipment. Okay, now I will give you a question. I don't want your answer now. Okay, just answer inside you. What happening for these 3 years? These are years, you know. We have the first year, second year, and third year. But what happened? All 3 of them have failures. Yes, I know. But what happening? To answer those questions, we need to go through tribology. So tribology is the most important science and tools that give us a good maintenance engineer. Let's go to the first step of life of equipment, early failures. As you know, any equipment or any component or any surface, we always imagine it as ideal, but in reality, any surface has what we call roughness. The peak of any roughness, we call it asperity. For example, this smooth gear is smooth in reality. It's smooth when we look at him, but in reality, it is full of roughness, full of asperities. So, in the first phase of life of an equipment, we have a lot of asperities. You know, the technology of manufacturing is developing day to day, but it is impossible to arrive to get an ideal surface. It is impossible. Always we have these roughnesses. Always we have asperities. So, in the beginning of life of the equipment, when we have 2 contact surfaces, the surfaces in contact start to have wear between them due to roughness and the asperities. In the early life, we have two main wear types. First of them is the adhesive wear. The adhesive wear happens when we have two surfaces in contact and their asperities will be micro-welded. We have welding and we have atomic junctions between them. This micro-welding happens due to the high local stresses. We know that stress is the force on section, but when we have a low section, which is the section of the asperity, some micrometers and nanometers, we will have a high local stress and high local flash temperature. Due to the stress and temperatures, we will have welded asperities. Now, when those two surfaces are sliding against the others, the sliding force will shear this micro-welding, and the asperities will be sheared and causing the failure of the surface. In this shear, we can see the mode of wear, which is adhesive wear. We can see high pitch due to the adhesive, to the shearing force. When we shear, after we have the adhesive wear, we will get a third body, a fragment that belong to one of the two surfaces. This fragment will cause another type of wear, which is the three-body abrasive wear. This fragment actually will oxidize after leaving his surface, and it will be very dangerous to generate the abrasive wear. In this shear, we can see this mode of wear, which is abrasive wear. We have another type of abrasive wear, which is the two bodies abrasive wear. This type of wears happen if we have two different materials. One is soft and the other is too hard. So the hardest materials will start to plough the softest one. And in this case, we will not have the adhesive, but we will have the two bodies abrasive wear. So those two types of wear will explain why in the beginning of life in equipment, we have such a high failures, because in the beginning, we will have a lot of asperities, a lot of roughness, because the equipment is new. So we have a lot of abrasive and adhesive wear. Because of that, the manufacturing companies always have their standards to keep this wear in control. After finishing the first step of life, we'll have a very smooth surface. We will not have such a high asperities and roughness, but just a very smooth surface. So the production company will purchase this equipment. It is now smooth. We will not have very high danger of failures. However, depending on the condition of work, we can have again some adhesive and abrasive wear. I mean by working conditions, the applied force, applied power, machine velocity, and the working duration. In addition to other types, we can have like erosion and corrosion. For erosion, the matter or we have some particles, tiny particles inside fluid. This fluid, when he moves with pressure, this flange has suffering from this type of wear to industries, because we have oil, we have some gases, and we have some sands inside them. So you will see a lot of these things, a lot of erosion during your work. It is very important to talk about the erosion or the erosive wear, which is the angle of impact. For example, if we have a surface made of ductile materials such as stainless steel or steels, which is the main materials for oil and gas equipment, if this angle is lower than 19 degrees, it will be too dangerous. And in contrary, if we have some hard equipment, so hard materials, the most dangerous angle is the 19 degrees. So this story of angles, you must to pay attention, to care about it. For the corrosion. The corrosion is the reaction between the corrosive environment and the surface. Generally, during our works, we can have two types of corrosion. First is external surfaces corrosion. I mean, the external surface of our assets. Because of that, generally, we paint our assets, not for decoration, but to preserve them from corrosion. Second type is the corrosion that happens inside the components. And this generally happens when we store our equipment in a wrong method for a long time. For example, let's take an example. Last year, we have the oil collapse, a lot of equipment were stored. If we store any equipment, any one of them, in a wrong way, when we start to work with them now, we will have a lot of corrosion inside them. And especially what we call the pitting corrosion, which is the most dangerous type of corrosions. The pitting corrosion reduces the dimension of our equipment. And this is a lot higher, very, very high dangerous. Now, let's go to the last phase of life of the equipment. Generally, when we arrive to the end of life of an equipment, we will have what we call it, the fatigue. The fatigue is, let's say, is one type of tribological problems. It happens when we have repetitive low stress on our materials, because generally stress, the failure happens on the equipment when we have local stress, which is higher than the elastic limit of the surface materials. But when we have repetitive low stresses, we will have the fatigue. And because of that, I said before, any small stress, any small force will damage our equipment when he's in his last period of life. So fatigue generally is the main cause for the wear out failures. Now, if we look to this gear is suffering from fatigue. And how we can recognize fatigue from other types? We recognize it from the smooth surfaces. If you look on the failure carefully, you will find that we have a very smooth surface, and this is due to the low repetitive failure, low repetitive forces, low repetitive stresses that cause the smoothing of the surface, and then we will have the a very damaging failure. Now let's go to, after we finished with tribology, and after we understanding the path or the life of equipment curve according to tribology science, let's go to understand what are the different types of maintenance. Mainly, we have two types of maintenance: the corrective maintenance, which is the maintenance performing after the detection of failure, and our mission in this case is to restore the equipment or the asset to state in which it can perform its required function. This is traditional repairing of equipment. The second type is the preventive maintenance, which is the maintenance carried out at predetermined intervals or according to prescribed criteria. Here, we can notice that we have two different words. The first is predetermined intervals, and second is prescribed criteria. In fact, those two words define two types of preventive maintenance, and we will see them later on. So, I said preventive maintenance is the maintenance carried out at predetermined intervals or according to prescribed criteria, and intend to reduce the probability of failure. In the corrective maintenance, we have a real failure. Our equipment is falling failure and is damaging, and where our mission is to restore it. However, in the case of preventive maintenance, we don't have a real failure. The failure is not occurring yet. However, we have probability of having a failure in the future. This probability function, we call it the reliability, or in French, we call it la fiability. Now, how can we choose between using or applying a preventive or a corrective maintenance? You know, in some equipment that we are going to maintain, it is not worth it to invest on them. It's not worth it to invest for preventive maintenance. For example, compressors, those tiny, small compressors that we use in our maintenance, we don't need to invest for preventive maintenance for them. We just correct them if they fall. Why I said that? Because, you know, the preventive maintenance is not an easy decision, you know, because you throw your money, you put your money for something is not happening yet. It is not logical, you know, to put your money for something it is probable to have. The failure is something fictive, is not reality. But we put our money in order to prevent it. So a lot of people can say that this is a throwing of money. This is not a reality. It's not logical. However, if you have a critical equipment and it falls, and we have a failure on it, it will be another damage. For example, I will give you a personal example. When I was in bachelor, I made a training in a company, Algerian company in Sumatra. It was a training of 1 week. During this 1 week, the mud pump, I don't know if you know the mud pump, is full. The people there, they didn't invest for preventive maintenance on these pumps. and during 1 week, a whole week, all the rig didn't work. This is a loss of money also. Not investing in preventive maintenance is also a loss of money. So how can we take this decision? We can take it by taking the optimal level of preventive maintenance. You know, if you see carefully on this curve, we have two different curves and a bathtub curve, which is a mapping of those two curves. First curve is the preventive maintenance cost. You know, if you keep investing in the preventive maintenance, the cost will increase with time. However, if you look to the corrective maintenance cost, it is reducing. Why? Why it is reducing? Because if we keep investing on preventive maintenance, the failures will be lower and the corrective maintenance also cost will be lower. So, and in the contrary, if we keep investing on preventive maintenance, it has no sense. It has no sense. Because, you know, we are not going to throw our monies. So if we map these two curves, we get what we call the optimal preventive level. If we look to in the right of this curve, we'll have an excess of preventive. That means we are just throwing our money or nothing. And the probability of having a failure is too low. However, if we look in the left of the curve, we see the lack of preventive. That means here we are in dangerous case and the failure can happen at any moment. So as conclusion, choosing for any equipment its level of optimal preventive is very, very important. We said before that in the case of preventive maintenance, we have two different types, according to the definition. We said there is a maintenance that's done at a predetermined interval of time, which is systematic maintenance, and the other is depending on a criteria, predetermined criteria, that we will see later on. So first is systematic preventive maintenance, and this type is carried out at predetermined interval and intended to reduce the probability of failure or degradation. Here in this figure, we can see different types of preventive interventions separated with different times, different intervals of times. Choosing the time or the interval of the intervention is very, very critical. If we take short intervals of times, I mean lot of interventions, we will have a lot of, we lose our efforts and our spars and our monies for nothing. However, the probability of having a failure will be too low. However, if we have a long period of times, that means very short interventions, will not cost a lot of money, but the probability of having failure will be too high. So choosing time is very critical also. The second type of preventive maintenance is the condition-based maintenance, or CBM. The CBM is carried out according to prescribed criteria and intended to reduce the probability of failure. Now, to understand fully this type of maintenance, let's use this curve, which is the curve of the CBM. As you can see here, this is a curve of efficiency as a function of service time. The efficiency is reduced with time. efficiency of any equipment will reduce with time. This is logical. We have here different aims. These aims are measures. Those measures can be direct control by eye on state of our equipment or our component, or can be done by using some sensors that giving us the information about the state of our components or our equipment. Those measures are done repetitively to control degradation of the equipment. Now, we must fix a threshold that we call the alarm threshold. So when data of our component or our equipment to this threshold, an alarm will be generated and the function of the equipment will stop directly, because if we arrive to eligibility threshold, there's already in failure, and the preventive maintenance has no sense at that time. So in order to avoid this problem, we should always fix before getting the failure on our equipment. Generally, the condition-based equipment, we invest on this type of maintenance when we have real critical and equipment that we don't want to get it stopped. For example, the case of mud pumps. You know, if the mud pumps stop, all the rig will stop. So this is an example of critical equipment that we need to really apply the CBM on it. Now, what is the reliability? We mentioned the reliability before, and we said this is the function that determines the probability of having a failed case of preventive maintenance. In modern maintenance, we don't have only the maintenance engineer, but we have two teams that works together, the maintenance team and the reliability team. Okay, I will tell you something about the history of maintenance. The maintenance started in the beginning by its first generation of maintenance, which is the repairing, just a repairing. You know, the first generation was between the 30s and the 50s, before the end of the Second World War. The end of the war until the 80s, we introduced the notion of preventive maintenance. So the maintenance engineer, it didn't work for repairing, just repairing, but for preventive maintenance and corrective maintenance. However, when third generation of maintenance started after the 80s, we introduced what we call the RCM, stands for reliability centered maintenance. That means any action done by maintenance team and any strategy done by the maintenance team was done according to the reliability engineers studies. For example, the time of interventions, they done according to the requirements of the reliability engineers. For example, whether we can invest on CBM or not, done by those teams. And this is third generation of maintenance. So in the current maintenance, in the new developed maintenance, we have a maintenance team and reliability team. So the maintenance engineer has a function of managing the maintenance activities to improve the availability and the longevity of the assets, as we saw before. However, the reliability engineer uses the data given by the maintenance engineers to improve the efficiency and the reliability of the assets. Because of that, and this is an important information, when you are done in your, when you are working on maintenance, the data that you are taking are very important, because there is a lot of people who just throw, for example, time of intervention, time of maintenance, the duration of maintenance. There is a lot of people who just put anything. In reality, those are the information that the reliability engineer used to improve the efficiency of your equipment in reality. So in RCM, we have three main definitions that we need to fully understand. The first of them is the reliability definition. So the reliability is the measure of the ability of an item. And I use here item, not equipment and not asset, item. And I will tell you later why. So it's the measure of the ability of an item to perform its required function without failure under stated condition. And I say again, stated condition during a specific period of time. Stated condition, what I mean by stated condition is if you have two equipments, the same equipment, for example, two pumps, but the first pump is working under very, very aggressive conditions. However, the second one is working on a soft conditions. It is not logical to expect that two of them have the same reliability. Because of that, stated condition of working is very important. The same for the specific period of time. If you have two same equipments, but the first working for a lot of time, for 1,000 of hours, however, the second who works on 100 hours or some hours, it is not logical to expect the same reliability for both of them. Because of that, mentioning the stated condition and the specific period of time is very, very critical in reliability science. The second definition in RCM is the maintainability. What is the maintainability? Is the measure of the ability of an item to be retained or stored. Retained means the preventive maintenance or corrective maintenance. First, right on the I say it condition. The first one is maintained by a skilled team, and the second one is maintained by trainees. It is not logical to expect that they have the same maintainability. Prescribed conditions also, we mean by this word also the existence of tools, prescribed procedures. There's some companies that have prescribed conditions, procedures of maintenance. You just follow those procedures and you will get a very good maintenance job. However, there is some companies that just do it. They have no prescribed, no procedures of working, just work it. So it is not logical to have the same maintainability for the equipment of the two companies. The third definition is the availability of the equipment. The availability is the measure of the ability of an item to be in that state to perform the required function understated condition at a given point of time. So the availability depending on the reliability and the maintainability. If you have an equipment with a good reliability and a good maintainability, it will be available at all time. However, if you have the inverse, your equipment will be in downtime. So let's talk about the time indicators. Each and every type of those three elements of the RCM has its own time indicator. Following this interesting figure, we can see that we have 5 types of time indicators. The first one is the MTTF, which stands for mean times to failure or to first failure, because this time indicator, we use it only when we purchase our equipment before the first, and I said the first failure. If we have the first failure, the MTTF is not, we are not going to use it after that, after the first failure. Second time indicator is the MTBF, or the mean time between failures. The third time indicator is the MDT, which is the mean downtime. That what means the time of the unavailability of your equipment. The fourth type is the MUT, or the mean uptime, which means the time of the availability of your equipment. The last time indicator, and the most important type as maintenance guide, is the MTT, or the mean time to repair, which is the time necessary time to repair or to do the maintenance intervention on our equipment directly to reliability. The MDT and MUT related directly to the availability. However, the MTT are related to the maintainability. Now, I think you remember the failure rate because we saw it before on the equipment life curve. The failure rate is 2 different definitions. Definition related to the services, to this general definition that we can understand it directly from the name of failure rate, which is the number of failure of the service on the service. However, the second definition related directly to, we can define the failure rate as probability function, which is the probability of the survived component at an instant t, taken from any sample. I mean by sample, some equipment of the same types. For example, 5 pumps. This is what is the probability of having the failure rate. So the variation of this failure rate gave us our famous curve, which is the butthole curve, or the equipment life curve. This is our famous curve. And let's define it not at this time by tribology, but by probabilities and by reliability science. So the most important, as we said before, the most important part or phase for us as maintenance engineer is the second type, the second phase, which is the constant or random failures. Random means in the probabilities. Random means the only solution of equipment in this phase can be solved using the probability or probability laws. So the question is, as maintenance engineers, we have our equipment in the second phase of life. How can we predict the state of life or the state of failures at any time, at any moment of time? To answer this question, the first probability law is the exponential law, and it is used for the electric components. The second law that we can use is the Weibull Law, which can be used for the electromechanics and mechanical components. For the electric components, generally the second phase is constant. So after millions and billions of studies done on the probabilities and the reliability of the electric components, scientists arrive equipment has a constant variation of failure, and you can predict any moment at time the probability of failure by just dividing one on your MTBF. That's all. However, in our case, the case of mechanical engineers, the things are harder, let's say. I know that all the mechanics engineers can agree with me that our life is very, very difficult. It is impossible something easy in mechanical engineering. So in our case, there is no constant. The failure variation is not constant with time. To get the failure at any moment, they must use the Weibull Law.
Hello guys, it's Intern, so we should wait for.
Mr. Riyad, can you hear me?
Yes, I hear you, sir.
I wish that we were interrupted just now. I don't know what happening.
Yeah,
Okay,
it was just now. So I think it's all about the internet. Yeah.
Okay. I will carry on. Okay, thank you.
All right.
So we stopped at here. Are we stopped here or no?
In this moment, we are not seeing the presentation. Could you please reshare with us your presentation, sir?
I don't know at which slide we stopped. I don't know.
So I personally didn't see any presentation. Here?
Oh, any presentation? Because for me, I thought that we done it. I don't know all of that. Are you suggesting to?
Yeah, I think you should reshare with us your presentation.
Okay, I will repeat it from the beginning. Okay. Do we have time for that or no?
No, I don't. Riyad, so you don't need research. Yes, I hear you, sir. So you don't need to repeat from the beginning. So I personally didn't see any presentation in the screen. So we were seeing it happened just now.
It happening just now.
Yeah.
Yes. So it is better to start from the beginning. That's it.
No, we stopped it in the page at the page 23.
But you heard the presentation.
Yeah, we do.
The presentation.
Yes, we did.
Oh, okay. I thought, okay. So we stopped here we saw before that in order to predict the failure, probability of having failure, to predict failures in the second phase of life, we should use the probabilities laws. In
Excuse
this
me,
case,
sir.
we have two different probability laws.
Pardon,
Yeah,
Excuse me.
could you please share your screen again? We can't see your presentation.
Okay.
Okay, thank you.
Okay.
Okay, now we can see it clearly.
Okay. You see it now? You're seeing it now? Are you
Yes,
seeing
we
it
do.
now?
Yes.
Okay.
Yes.
So we said that to predict the probability of having failure during the second phase of life of an equipment, we can use two types of probability laws. First is the exponential law, but unfortunately, this is just for the electric components. And we have the second law, which is the Weibull Law, that we use for the case of our equipment, like the electromechanic and mechanic components. So in the case of the electric components, we generally consider that the failure in the second phase is constant. And those are the result of thousands and billions of studies that done before. And they arrive to this conclusion. Second phase of life of an electric equipment has a constant failures, and the same failures can have it. You can have the same failure at any time. And we can calculate it directly by dividing one on the MTBF of your equipment. However, in the case of mechanic and electromechanic components or equipment, the failure variation is not constant and is varying randomly. And to have the correct answer for that question, we need to use the Weibull law. And this is Weibull law. It says the probability of having a failure at an answer equal on beta on eta multiplied by 1 minus gamma on eta power beta minus 1. This is just a law. It's not something difficult, because generally to get an answer, we can use what we call the Weibull paper or the log-to-log paper. To use it, we just follow the steps. The first step is the classification of the number of your components according to their TBF, or time between failures. I mean by that, if you have a sample of, let's say, 6 pumps, we just go into their history and get their TBFs from the beginning until that instant. Then we just classifying them according to, from the lowest to the highest one, in order to get what we call the order value I. From now, let's call the TBFs by T. We will referring them to T instead of TBFs. For example, we will take an example of 6 equipment, same type. In this table, we ordered this equipment from 1 to 6 according to their TBFs. The lowest TBF was 165 hours, and the highest one is 1,324 hours. Now, the second step is the calculation of FI. This is a function, just a function that represents the reliability, approximative reliability value. For example, if we have a number of samples lower than 20, we can calculate this Fi using this law. We have I, which is the order, and N, which is the number of the equipment. In our case, is 6. And if we have the number of sample variated from 20 to 50, we just use this law. And if we have the number of equipment higher or equal to 50, we will use this law. Now, in our case, we have 6 equipments. That means we will use the first law to calculate the Fi. Now let's go back to the Weibull paper in order to understand it. The Weibull paper has 4 different axes. First axis that we refer here by I. I don't know if you can see this uppercase I on the paper is the axis of TI, or the TBFs of the equipment. And the axis of B that we refer with B, with the uppercase B, is referred to the Fi that we are already calculated using the first law. The third axis is the lowercase I, which is the which is used to put the values of the logarithmic of Ti. The axis lowercase b is then we use it to represent the point of calculating the logarithmic of logarithm 1 on 1 minus Fi. So the third step is just presenting the 6 points calculated before, which are referred to the Fi and to T, which is the TBF, to get this line, this straight line that we call D1. The intersection of this line with the uppercase I axis give us the parameter of eta, which is in this case is 770 hours. If we have a straight line, really straight line, that means our gamma is equal to 0. For beta, we just represent a parallel line of the D1 starting from the origin, XY. The intersection of this line with the lowercase b axis gave us the beta value, which is in this case 1.4. Now, in the case we haven't the straight line of D1, not straight D1, we need to adjust the obtained curve. But however, in this case, we should know that gamma is not equal to 0. Now, in order, as we saw before, not all the equipments are the same. There is some equipments that are critical and that need to pay more attention on them. I mean by putting more attention on them, I mean, for example, invest more on the CBM and on the preventive maintenance of them. The preventive maintenance level will be higher on them in comparing with the other equipment. So the idea that you must put in your head is not all the equipments are the same. Not all the equipments have the same value, same priority. So between all the existing equipment, there is some that needs more care to improve their preventive maintenance action. The classification of those equipment is according to the time. Can you hear me? MTBF, the MUT, and the MDT. Okay, okay, thank you. I said, as I said, the classification of this equipment, of the priority of this equipment, is depending on the MTB, the MUT, and the MDT, and MTTR. That means the data that you are taking during your action. So there is different methods for classification of the priority equipment, and the most used one is the Pareto method. So the Pareto methods give us theoretically, I said theoretically, not in reality, it allows us to determine 20% of equipment responsible for 80% of the total MTBF or MTTR, MDT, or the MUT. This is theoretically, but in reality, this 80% and 20% can vary. For example, 60% of equipment are responsible, for example, of, let's say, 50% of the MTBF or the totality of equipment. Let's take this example to understand the Pareto method. The first step of a Pareto method consists of defining the objective of our study. This objective could be the equipment responsible for the most of MTTR, maybe of the MDT. In this example, for example, we will use the objective of the equipment responsible for the most of the downtime.
Hello, sir.
Hello, sir.
Can you hear me now, Riyad?
Yes, I do know.
Okay. So after defining the objective of our study, we should put them in a table. In this table, we put the equipment. For example, in my case, I didn't give them a name, but I give them a reference. For example, the 234 stand for example, a pump. 235 stand for a choke manifold, for example. And in the right, we have the downtime and availability time for them. Now, we should classify. The third step consists of classifying them by decreasing value. And we must calculate the cumulative of the objective, cumulative time of the objective. For example, the equipment reference number 196 has 28 hours of downtime. And the equipment 268 has a downtime of 15 minus 28. You see, we are here accumulating the downtime. After accumulating these times, we just represent the Pareto curve, which is the cumulative downtime as a function of the equipment classification order. In this example, we can say that can give a conclusion of that 60%, I mean the 8 first equipments are responsible for 55% of total downtime. And those 8 equipment need to take care about them because they are responsible of more than half of the unavailability of the totality of your equipment. So we must for this equipment, for this 8 equipment. This is the how can we define and classify the priority equipments in our case. Those 8 are Sir, can you hear me?
Yes, we can hear you, sir. You can go ahead and continue.
I said after finishing the maintenance engineering presentation, I added this page. And the slide to most of you are going to become in the future, maybe not a maintenance engineers, but something, why not? To become maintenance researcher, you have some fields that you must on in order to develop scientific first field development and new materials and coatings to enhance the tribologic properties of Riyad, can you hear me?
Yes, I do know.
Okay. So as I said before, every one of us can become not just a maintenance engineer, but a maintenance researcher. So to become a maintenance researcher, there is a lot of fields need to be improved by you. And one of them is developing new materials and coating to enhance the tribological properties of any equipment, of any surfaces. Because as we saw before, the tribological problems are main problems for any failure. So by developing new coatings and new materials, you are fighting against the failures. There is another field to be improved by researchers, which is the reliabilities, methods, and models. In all the world, there were students like me, they were my colleagues. And they developed wonderful methods and models to improve the reliability of, especially of petroleum equipment. And your duty as a reliability researcher is to increase the probability of having a reliable equipment from 15% or 40% and to get into the 100%. There is another field to need to be improved by maintenance researchers, which is the failure investigation analysis. For example, in this figure here, this figure made by a friend of mine who is doing research on the failure investigation for blades of turbines, and this is a photo of blade of turbines by microscopes. So this is three main domain needs to be improved by maintenance researchers. At the end, I want to thank you for your attention. And I don't know, I think today we have a lot of issues with the network. So I'm sorry if the problem is from my network. If you have any question, you can send it to me across my email or my ResearchGate, LinkedIn, and Facebook profile. Okay, thank you very much.
Thank you so much, Mr. Chemaa, for the effective presentation. It was really rewarding for us as students to learn and enhance our knowledge.
Thank you. Thank you.
So we have some questions in the chat. You want to check them, or I can read them to you?
I prefer to from you to read them.
All right. So the first question about predictive maintenance using machine learning algorithm.
Machine learning algorithms.
Yes.
You mean maintenance by machine learning algorithms? That's it.
Yeah, maybe.
Okay. If this is the meaning, we can use the artificial intelligence in their reliability domain. You know, as I said before, the reliability it is not in a probability law. It is impossible to get to 100% of probability of the failure or of the insurance that your equipment is fully working. So by using the artificial intelligence and some developed models, I mean, by developed models, not just the simple that we saw before. No, it is a real models. They are real models that we cannot solve in them before without using artificial intelligence. So our mission, the mission of artificial intelligence, is to arrive to this 100% of probability. This is the mission of artificial intelligence in the maintenance domain, is to arrive to the probability of having that 100%, either in the maintainability or the reliability or the failure occurring. Because as I said, that phase, the second phase, is the most important phase in maintenance, and we must arrive to the 100% or 90% of insurance that we have failure. We must arrive, and the artificial intelligence is here to help us to arrive here. And there is a lot of research, a lot of papers and scientific papers that talk about that. So Nihad, she can check them, and she will get a lot of information, a lot of algorithm. Okay.
Okay, your answer. I have worked in the oil and gas industry.
As I said, we have, if we are working with the the failure in occurring according or using CBM. So before to the failure, this the alarm without the intervention of anybody. And if we have a virtual failure, and we are fighting against it, so we are preventing them, but probably not sure. But in the case of CBM, we are avoiding them by shutting the equipment systematically after we arrive into the alarm region.
Yes.
Okay.
One of the participants said, most of the time, manufacturing recommendations are not followed properly, such as type of lubricant oil, viscosity. The technician using.
Sorry. Can
Yes.
you repeat the question, please? I didn't hear the beginning of
explained
it.
and he asked it.
Okay.
Yeah. So he said that most of the time, manufacturing recommendations are not followed properly, such as type of lubricant oil, viscosity. The technician using low profile oil that affect the reliability of internal parts that will lead to high friction and breakdown, causing huge MPT, especially when performing the job in oil and gas industry. Please, is this point critical? Sorry, please, this point is critical, especially during saving costs culture was implemented in last few years. Did you hear me, sir?
No, I didn't hear you. Didn't hear the question, but I'm reading it here in my chat. I'm reading it. So.
Right. Yeah, it's better.
To understand the question, then I will answer it. Is it better to read it?
Yeah, I post it again in chat.
Okay, I will read it. Okay, our friend said the most of time manufacturing recommendations are not followed properly, such as type of lubricant, oil viscosity. The technician using low profile oil that affect the reliability of internal parts that will lead to high friction and broke down, causing MPT, especially when performing the job in oil and gas industries. Please, this point is critical, especially during saving cost culture. What culture was implemented in the last few years? Look, if we have bad recommendation from the manufacturing, this is the utility of the reliability team. You know, the reliability team is not a constant team. He's working at every moment. You give him the data, he's calculating and improving the, for example, the interval of times of interventions. For example, the lubricant, for example, that you should use. For example, what is the problem? Because the reliability team is not doing just calculation, but sometimes they do some investigation. What this equipment is for? What this equipment is always falling? Why it is not the other equipment, but this equipment? So they did what we call the failure investigation, and to arrive, for example, to a conclusion that the problem is related with a bad lubrication, bad recommended lubrication, for example, or bad recommended systematic prevention intervention time, for example. So this is the job of the reliability team, and they can give us the answer for these problems. Okay. Okay, can you hear me, Riyad? Hello. Can you hear me?
Okay, so
did you hear the answer, or I will repeat it?
hello.
The answer, did you hear it or no?
Okay, sorry.
Hello.
So, sir, I think Riyadh has some network issues. Yes, the answer was clear. We can go ahead and go to the next question if you want.
The answer is it clear? The answer.
Yes, the previous
third
one.
answer. Okay.
Both the statements.
Okay. All right. So I will read. The fourth question was about periodic verification
Yes.
of processes. Okay, process. The functional performance of an instrument is often necessary to meet the external or internal compliance requirements. How to ensure the verification of the instrument without interrupting the process? There is sensors, for example. For example, in this case, if we're talking about the CBM case, we have verifications either by eye verification or using sensors. So we are not going to interrupt the production or the exploitation of our equipment. In reality, the equipment will stop only when we arrive to the alarm threshold. That's all. Okay. Okay.
Yes.
So can I go ahead or?
Yes, go ahead. Yeah.
Okay.
I think the answer was clear.
Okay. So the other question was about data analysis and statistics role was not highlighted as important factor in preventive maintenance. That is necessary to avoid exposing equipment to risks of breakdown. during the critical jobs. I think I said that I don't know, maybe yes, maybe I didn't highlight it. I didn't give it the necessary time, but I said, for example, data analysis are done, but are done by the fiability time or the reliability team. Okay, and we take the half of the session about the reliability. I think reliability and that is still give them the half of the session. So I don't think that we didn't highlight it and we didn't give them the necessary time. So the other question, how do we decide if an equipment is in need of preventive maintenance? What are the norms for it? Look, for norms about the preventive and corrective maintenances, we have the AFNOR, the French norms, and I think this is the most used in here in Algeria, the AFNOR. And how do we decide if an equipment is in need of preventive maintenance? This is the job of reliability team. Look, in the beginning, when we purchase an equipment, when we purchase it in the folder of this equipment, we have all necessary informations about the times, about the intervals of times needs to be done to do the interventions, the preventive interventions on them. But with time, changing or improving those intervals of preventive maintenance are the job of the reliability team. And this is the sense of developing the maintenance and going from preventive corrective maintenance of the second generation into the RCM of the third and the fourth generation. Okay, so deciding in the beginning of life of the equipment is depending on the folder of or on the advices of the manufacturer. But after the some times of working, it depends on the advices and studies of the reliability team. Okay, so next question. Constantly used devices can cause problem to the influence of process, which can reduce measurement performance, leads to costly and planned downtime. How is real-time data measured for trend analysis and predictive maintenance? Look, I will read it again, constantly. I didn't understand what he means by constantly using devices. I didn't understand them. Constantly using devices. I don't know. Is he talking about the processes or about tools? I don't know. Or about the exploitation, the devices of exploitation of the equipment. I don't know. They didn't understand the question. Which can reduce measurement performance, lead to constantly and plan it down. How real time data and predictive maintenance. I don't know if he can give me this question again with more clearly, because I didn't understand it in this form, you know.
I think the person that asked the question is still with us, so I'll try asking him to reactivate his mic.
Okay. Thank you. Now, the question of Nihad, what about predicting failure using data science? If you mean by data science the failure analysis, I don't know if you mean by failure analysis. I mean you have a failure and then you must do some investigations to know the origin of this failure. You must to do an expertise to see where and in which conditions your equipment was working on. For example, how much times, where is the region that it was working on. I don't know if this is your question about about the failure analysis. So if it is about the failure analysis, this is it. You must to do, and not you was going to do this mission, but the reliability team. They must to do the failure analysis of the critical equipment, of the priority equipments that fall a lot of times in failures. So this is the job of failure analysis, to do the expertise, to do their failure analysis in order to know the structure of life of this equipment since the day one until arriving to failure. And according to this, the recommendation of the failure analysis team, they will predict failure of any equipment, for example, working in the same condition, or any equipment of the same type, or the same of the same trend, or something like that. The question of Listel E-field is, we stop at page 23, yes. Now, the second question of Nihad is, for rotary machine as example. Okay, is it related to the first question? I don't know if this question is
sir,
related
I think
to
Nihad just
the previous
added,
question of Nihad. Yeah.
she just added the clarification, the last message. She's saying that, but data science, she meant machine learning algorithms that are used for predictive maintenance for rotary machines in industry 4.0.
Okay.
And she's asking whether it's used in Algeria yet.
There is researchers, of course. There is a lot of PhDs here in Algeria using the reliability algorithms in order to predict failures, in order to predict the maintainability of the equipment in the future. And most of them, especially in Boumerdès, they did it for the pipes, for the oil transportation pipes, because they have long longevity, long of service time. So they do a lot, and you can find a lot of interesting jobs, interesting research, interesting articles of your teacher, for example, the teachers of Weibull University. They did a lot of work in this domain, especially for the pipelines, for example. They did a lot of works about this domain. And you too, I don't know, she can do her PhD in this domain. You can do it. I don't know, just share presentations. Okay, I will share it with you. There's no problem. If you have any question, guys, okay, I would be greatly appreciated if you can get a copy. Yes, I will give it to you. Very informative session. Thank you very much. Are we using predictive maintenance of industry 4.0 in Algeria? I didn't hear about the predictive maintenance of industry 4.0. I'm very sorry, I didn't hear about it before. I don't know if you mean by, I don't know. Is it the fourth generation of maintenance? I don't know. Very sorry, I can't answer this question. Data science, I mean machine learning algorithm. Yes, I answered this question before. Look, if I'm not specialist in machine learning algorithms, but I think you can have a lot of informative things in a research paper. Just go to ResearchGate or something, and you will find a lot of things about machine learning algorithm. I'm very sorry, I'm not specialist in this domain. I'm very sorry, but if you are talking about the about the algorithm of reliabilities, yes, there's a lot of Algerians who did this before, and they're still doing. So I think I finished all the questions.
Yes, that was the last question. Like, if anyone has any other question, kindly drop them in the chat box below. But I do think that was the last one. So I'll just go ahead and clutch the session. Thank you once again, Mr. Khaled, for this very really informative session. It was really beneficial for us. And thank you everyone who
Thank you very much.
attended and stayed with us even despite some technical issues that we had. It was a really interesting session. You can find the recording on our YouTube channel. So we'll share the link with you after all, so you can check it. So you can go ahead and check it out. If you have like any additions or anything you'd like to add, sir, the mic is yours. Hello. So I guess there is no additions. Thank you once again, Mr.
Thank you. Thank you. I think the network issue can.